All right, guys, so today we're going to be going over our Unit 9 quiz review. Just a reminder, Unit 9 is all things rational functions, so we're dealing with a lot of polynomials and fractions and everything that's going with that. And this is all in preparation for your quiz, which is very, very much aligned to your exam that's coming up as well. So let's go ahead and get started. So our first problem here, we have x and y vary inversely. X equals 5 when y equals 9. Write the function that models the inverse variation. So for questions like this, I just want to recall direct variation is y equals kx. And I taught you guys it's just directly across, right? It's all one line. Inverse variation is where we have the inverse between y and x. We'd have y equals k over x. Okay? And this is our setup here. Now for this problem, it says that x and y vary inversely. So we're going to be using this equation here. And so when we're using that, we need to solve for x. Okay? I'm sorry, not solve for x. We need to solve for k. Solve for k, right? And to do that, we're going to substitute our x and our y into the equation. So we'll say 9 equals k over 5. We want to solve for k here, so we want to simplify out this 5 in the denominator. We're going to multiply both sides by 5. 5 times 9 is 45 equals k. I'm going to box this, not because this is our answer, because we got to write the equation, right? We got to write the function, but it's because it's important. So our function here, now that I know what k is, given this model, we can always use the equation y equals 45 over x. And this here is our answer. Okay? Now that I know what k is. And if they gave us another scenario, if they gave us y or gave us x, we should be able to solve for the other one now that we know what k is. Okay? So now this is your question here. X and y vary inversely, so you need to determine, are you going to use the direct variation equation, or are you going to use the inverse variation? X is 9 when y is 8 to come up with the function. So you got to solve for k first. That's your hint. If you have any questions, send me a message. I'll be more than happy to help. Let's move on. All right, so this next one says, Charlie is selling homemade cupcakes. He found out that the number n of cupcakes, okay, so we're talking about n here. Typically, whenever they start off with these types of questions, that's usually going to be your y value, right? So we're saying n cupcakes can make varies with how much time he spends mixing his ingredients. And so that should have been varies directly, right? So we're going to say y equals, or in this case, we can also say n equals, we'll do it both ways, with the time you spend with the ingredients, so it'd be kx, right? Kx, same thing. And inversely, with the time he's baking. And this is y is what he's baking with. And this is where it gets confusing. So this is why we don't want to go with this y. We're going to go with this n value here over y. So this is the equation that we came up. This is a compound. Okay? It says Charlie is able to make 24 cupcakes. So that means that our n, the number of cupcakes, is 24. When he spent 3 minutes mixing, well, mixing was our x. So x is equal to 3. And 24 minutes baking. Y is equal to 24. Okay, so they want us to determine how many cupcakes can he make when he spends 8 minutes mixing his ingredients. Okay, interesting. Well, we want to solve for k. We want to solve for k here. And so when we set this up for k, we're going to say 24 equals, our k value is what we're looking for. X is 3 over 24. Okay. And so what we want to do here is we want to isolate k. So we're going to multiply both sides by 24. So we'll have 24 times 24. That's 576 equals k times 3. We would then divide both sides by 3. And we get a k value of 192. I'm going to box that. That's important. So knowing that, our new equation would be n equals 192 x over y. I'm going to box this. This is also important. Okay. So then determine how many cupcakes Charlie can make when he spends 8 minutes mixing. So now he's spending more time mixing. So now we're going to have to solve this one. X is equal to 8. The baking time is going to stay the same, right? So that baking time is still going to stay at 24. And they want to know what is n. N is what we're solving. Okay, so we'd plug all this in. We'd say n is equal to 192 times 8 over 24. So n in this case, well, 192 times 8 is 1,536 over 24. So we divide that by 24, and we get that n equals 64. Okay, and this is how we'd solve that. All right, guys. Take the time. If you need to pause this, go through it. Remember, we annotate, we come up with our equation, all that good stuff. If you have any questions, send me a message. We have the exact same scenario here, so it's going to follow the same rules. I just want to make sure that you guys understand. Use n as our leading value. That would be our dependent variable. Use n. Don't use y, because they use y as part as the time baking. Only thing that's changing is the numbers, so I want you guys to practice this routine here. Again, if you have any questions, send me a message. Let's go ahead and move on. To simplify the rational expression and state any restrictions in the variables. Okay, cool. So let's do this. We've been doing this for quite a while here. We know that I see 1, 2, 3 terms in the numerator, so I know that I need to try breaking this down into 2 binomials. So to get x squared, well, that would be x and x. X times x is x squared. I want 2 numbers added or subtracted to give me 12, but multiplied to give me 35. Well, that'd be a plus 7 and a plus 5. Over 1, 2, 3 terms, trinomial. Let's break that down into 2 binomials. Okay. And I want 2 values that multiply give me x squared. Well, that'd be x and x. 2 numbers added or subtracted that give me 4, but multiplied that give me negative 5. Well, that would be a positive 5 and a negative 1. 5 minus 1 is 4. 5 times negative 1 is a negative 5. Cool. So this is factored. It's not simplified. We still need to simplify this out by seeing and understanding that this binomial pair of x plus 5 and x plus 5 can be simplified out. So we're left with x plus 7 over x minus 1. And this is our simplified answer. If we were asked to solve for wholes, vertical asymptotes, and all that good stuff, we could then use that x plus 5, but it's just asking us to simplify it and state any restrictions. So while this is our answer here, we do have a restriction where we got to take this value of x minus 1 and set that equal to 0, and we get that x equals 1. What that happens, or what that means is we'd have an undefined value. If I put a 1 here in the denominator, 1 minus 1 is 0, any value divided by 0 would be undefined. So our final answer would be x plus 7 over x minus 1, where x cannot equal 1. And that's your answer. In other words, that's where we're going to have an asymptote, a vertical asymptote to be more specific. Okay? Same skills we've been doing, just a different way of asking the same question. Let's go ahead and move on. You guys are going to do the exact same thing on this question here. You're going to want to split up that numerator into binomials, split up the denominator into binomials, see if anything simplifies out, simplify them out, and then find out where you're going to have those vertical asymptotes. All right, let's go ahead and move on. All right, so simplify and state any restrictions on the variable. So now we have division here. You'll recall with division, it's the same thing, but we'd have to multiply by the reciprocal. So what happens here is we really have n squared minus 3n minus 18 over n minus 6 times, when we flip this here, we'd have n squared minus 4n minus 12 over n squared plus 5n plus 6. And this is what we want to then start simplifying out. So let's get started with this first numerator here. We're going to see, can we split this up into two binomials? I'd have n and n. Two numbers added or subtracted that give us -3, but multiplied give us -18. Well, that would be a -6 and a +3, right? -6 plus 3 is -3. -6 times 3 is -18. All of this over n minus 6 times, and here we have another trinomial that we're going to try breaking down. To get n squared, there would be n and n. Two numbers added or subtracted that give us -4, but multiplied give us -12. Well, that would be a -6 and a +2. -6 plus 2 is -4. -6 times 2 is a -12. And then our denominator, we can break this down. To get n squared, that would be n and n. Two numbers added or subtracted to give us 5, but multiplied give us 6, would that be a +3 and a +2. So this was a lot of simplifying. I'm sorry, a lot of factoring. Now we want to start finding our binomial pairs. Well, I have an x minus 6 and an x minus 6. These two are the only ones that can simplify out. I can't also simplify out this other n minus 6 as there's not another pair for him. And then I have an n plus 3 and this n plus 3 in the denominator. I have an n plus 2 in the numerator and an n plus 2 in the denominator. Cool. So that just leaves us with n minus 6. And there are no restrictions at all to this, as we don't have anything in the denominator. X can be anything, or n in this case can be anything. So after all of this, okay, we were just left with an n minus 6. All right, so let's go ahead and move on. This is a lot of the same scenarios. The only issue with this one, and I want to talk about this, we have this -n squared. We see that happen twice here. When that happens, guys, just factor it out. What that would look like, if I factor out a -1, I would have n squared minus 16n minus, or actually plus 63. Let me go ahead and fix that here. Plus 63. It changes all the signs. If I was to distribute this negative back in here, well, then we'd have -n squared, positive 16n, negative 63, right? Over, okay, n squared minus 13n plus 36. And we're going to go times, I'm already going to help you out here, just remind you that you want to take the reciprocal, or the inverse, all right? And so this, we'd have n squared minus 16n plus 63. We're going to factor out that -1. So we'd have n squared minus 14n plus 49. So you want to factor everything out. I'll tell you this right now. All of these are factorable into binomials. And then you're going to want to start simplifying values out and see what you're left with. If you have any questions or concerns, send me a message on Teams, guys. All right, guys, on this one, I just want you to graph the given function and identify all your asymptotes. The only one that I'm going to really give you on this one, I want you guys to do this one, is vertical asymptote is going to happen at when x minus 2 equals 0. So at x equals 2, we're going to have this vertical asymptote here. Okay. There will be a horizontal. I want you guys to identify that. Use Desmos for this question. Graph it, do the best you can. this is a question. I put this in here to get you to practice your graphing skills on Desmos. But I've already helped identify that vertical asymptote. There is going to be a horizontal one as well, but where? I want you guys to find that out. On the next one, same situation. I want you to tell me where's your vertical asymptote, where's your horizontal asymptote, and give me the graph. That concludes our review here for our quiz. If you have any questions, send me a message on Teams, guys. And best of luck. We'll see you all later. Bye.